All right, so if we trace the path of the wind, 30.2, 30, 29, 28, and here 30.1, 29.9, and then down here 30.4, 30.3, 30.2, 30.1. And the same general idea is seen here. We have this big cold mass of Earth, and then we have warmer waters. And so it's going to go cold to warm. So it's going this way, and then once it hits the warmer waters, the wind speeds really pick up. But what's really apparent is what happens when big fronts get together. So we have this large front of pretty much the same pressure. And on this side, there's a large front in the 60s. And then this portion in the 60s over here. And there we go. This large portion in the 60s over here. And let's see. So those islands need to be visible. There we go. And then as far as pressures are concerned, we have a higher pressure area here. And we have a higher pressure area here. And wind is flowing from the high pressure to the low pressure. And it's kind of getting squished. And so if we look at wind speeds, we're looking at 25 miles an hour, 13, and then as they get squished, they get up to 35 or so, 37. And then, so I'm wondering if there's some sort of I don't know if I'm using this correctly, but like a Venturi effect. Because the paths that the wind has to go through, it's kind of getting squished. And so it's the same volume of air, but going through a smaller channel, and so its speed increases. But as far as going from cold to warm, checks out. Generally, cold, warm, cold, warm, cold, warm. But what's happening here? Let's see, so that's off Halifax. So that's temperature, that's air pressure. So I think what we're looking at is so let's put this in the center of that window. So we're pretty much looking at the portion east of Charleston. Yeah, so these are our areas that we're comparing. And over here we can see that we have some warm air. Warm going to cold. So the question is why? I think it's because it's being sucked into that. right? Because you have the cold to hot rule applying in the eastern U.S. Wind is going off. It's being met with warmer temperatures over here. And so this wind front is kind of being split. Part of it is going south, part of it is going north. I think that the whole reason why there's warm stuff here is because this is generally warm stuff, and there's generally cold stuff up here and generally cold stuff up there. And then they both go towards this big warm mass, and then they kind of squish it and they squeeze it up a little bit. And if that's true, then when I zoom out, it eventually dissipates. Okay. So I think one portion that would be okay, so I think that we've concluded that in general the cold to warm rule applies. And when it doesn't seem to, it's because there's larger effects like things getting squished. When we just focus on air pressure over on the right hand side of the screen, it might be useful to find, whoa, what's going on over here? Okay, don't get distracted by the shiny things. So let's look for kind of a turbulent area. Because one thing that I was wondering is if it's just about solar energy and just warm to cold, or cold to warm, high pressure to low pressure, then you would think it would be more of a constant wind speed, but it's not. So here we have cold, less cold, warm, warm. So what would be a good area to focus in on? How about here? So here, how about here? So we have a really low pressure area here. Excuse me, high pressure. So high pressure, low pressure, real low pressure, high, low. So one of the pinch points is this easterly wind here, this northerly wind here, both existing for good reasons. And then if we look at wind speed, 8, 12, 29, 28. And then if there is like a Venturi effect or whatever from getting squished, 31, 35, 32, 30, yeah. So roughly true. So the reason, so the reason why it's a little bit more complicated is because, of course, it's more complicated. It's the Earth, and the Earth is rather complicated. And there's a lot of different local systems merging into a big system. And when they merge, sometimes different fronts hit each other in different ways, and it creates kind of local effects. And sometimes things get squished and wind speeds really pick up. And also the fact that this is just at sea level. So what if we were to take a look at temperature air pressure. I don't really care about temperature anymore because we've already decided that happens. So why don't we put wind speed on the right? Left. Okay, so what if we zoom out here? Let's just take a look at the Atlantic. Okay, that's roughly the same. Okay, roughly the same. Let's change our altitude. So we'll go 250 meters off the ground. Whoa, baby. What happened there? So that's geopotential 850. All right. So on the right, we're looking at, see, that's 29.2 down low. 29.2 there, 30.4. Wow. So basically, like, I don't have the patience and brain power to read that meteorology textbook in full right now, or maybe ever. But suffice it to say that wind generally follows the cold to warm rule, and because it's not in a vessel of limited volume that cannot expand, cold can be higher pressure, and higher pressure goes to lower pressure, and there are lots of different systems interacting, and that's why it doesn't appear painfully obvious and linear and just straight across the board. And then compounding that is that this is obviously like three-dimensional, and so we have the interaction of pressure, temperature, wind, all sorts of stuff at different altitudes. So that's at 300 HP, and then we have the interaction of thousands of different factors. So like, why would it be at all, holy shit, simple or intuitive? Wow, 156 miles an hour. So air pressure, 30.4. That's real fast. Wow. So let's look at temperature. Oh, it's all pretty cold up there. So here at 30,000 feet, that's interesting. It's all, the pressure is pretty similar and the wind speeds are really different. So maybe that tells us that there's a lot going on underneath that's affecting up above. Oh, I'd like to see a 3D animation. But at any rate, it roughly works like they say it does. And the reason why sometimes it doesn't seem to is because it's complicated as shit. But generally, cold to warm, high to low. Checks out.